Hey y'all, so this is the first video you're going to be watching for our unit on with the flipped classroom to see how you like it. It's going to be on graphing quadratic functions. So as you go, fill in the notes that I gave you in class and enjoy. So, if I can get this to work, here we go. All right, so quadratic functions, they graph something called a parabola. So I know I'm in the side screen over here, but it's called a parabola. That's the shape that it's going to form. They look like this. They can either open up or open down. So you have a graph there. I want you to just do a nice little rough sketch, just like that. They can open up or open down. If the parabola opens up, then the lowest point is called the vertex. And you can also call it a minimum because it's the lowest point that exists. The second one there, when it's opening down, that means the vertex is going to be your highest point. And you can also call it a maximum because, again, it's the highest point. So that's as high as it can go. The standard form of a quadratic is y equals ax squared plus bx plus c. We've been seeing this in the last unit when we were factoring our quadratics. The parabola will either open up or open down based upon the a value. So if a is positive, then it's going to be opening up. So you can see there right above your parabola, right in a is greater than 0. So the parabola is going to open up if a is positive. So think of like happy, and you're smiling, smile. If it's down, like a frown, then that means the a value is a negative number. And so again, please write in this a is less than 0, a is greater than 0. Big thing here is a cannot equal to 0, otherwise we wouldn't have a quadratic. It would just be left with a linear because there would be no quadratic term. They are symmetric. There is a special line that can be drawn straight through the vertex. So remember, the vertex is the highest to the lowest point, and there's a line that can be drawn straight through that, and that is called your axis of symmetry. And what's nice about it is you can fold your parabola right in half on top of itself. So make sure you are drawing that in and calling it the axis of symmetry. If we graph one side of the parabola, which is what we're going to be doing, we can then reflect all the points over the line of symmetry. And then we can graph the other side, and then we just connect the dots. So if you were to graph just this one side like this, we draw in our axis of symmetry, we can mirror everything to the other side. So again, the axis of symmetry is always going to go through the vertex. So to find the axis of symmetry, you need the equation, which is x equals negative b over 2a. The best way we can read it would be the opposite of b divided by the quantity of 2 times a, because the idea here is that if the b was negative, you would change it to the opposite sign of positive. If it was positive, you would change it to a negative. So the opposite b divided by a quantity of 2 times a. So here's an example for you. We have y equals 3x squared minus 18x plus 7. We're going to do negative b over 2a. The a value is 3, found right here with the x squared. The b value is negative 18. So when we plug it in, it's going to be opposite b. So instead of a negative 18, it becomes a positive 18. And on the bottom, it's 2 times a. Well, the a value is 3, so that's where I got 2 times 3 from. So if I were to simplify that, we're really doing 18 divided by 6, which is 3. Okay? So the axis of symmetry always goes through the vertex, so make sure you remember that. And then the axis of symmetry gives us the x-coordinate of the vertex. So if you were to do negative b over 2a, and since it's going straight through it, we know what the x value is. That's why it's x equals negative b over 2a. If we want to find the y value, then we would have to do a little bit more. So let's go back to this example just to review it another type. So we have negative 2x squared plus 8x minus 3. We're going to do negative b over 2a. That gives us negative 8 times over 2 times negative 2. So the denominator is negative 4, which means our x-coordinate of the vertex is positive 2. Okay, we're just continuing it now, just I'm doing on a different slide. So we have gone through and found the x equals the axis of symmetry, which was positive 2. We just found that. So then the next thing we're going to do is take that value that we just found, the x equals 2, and we're going to substitute it back into this original equation right here, and that's going to give us the y-coordinate. So in other words, we're going to do negative 2 times 2 squared plus 8 times 2 minus 3. Remember, order of operations tells us to do 2 squared first, giving us 4, then multiply by negative 2. Same thing here, 2 times 8, and then minus 3. So our result is 5. So again, 2 times 2 is 4, times negative 2 is negative 8, 8 times 2 is 16, then we're going to combine it all together to get 5. So that means the vertex is 2, 5. And that's one of the first points that you're going to plot on a graph. So let's follow through and continue to graph. So 3 steps to graphing. Step number 1, find the axis of symmetry doing negative b over 2a. Step number 2, find the vertex, and you're going to do that by plugging that x in that you just found. And then step number 3, find 2 other points and reflect it to the other side. And that's going to give us your 5 points altogether. So the vertex, 2 points, and then reflect it to get 2 more points, and then you can draw your parabola, which is that U shape. What you're going to do to find the other 2 points is we're going to make a table using the x values that are going to be close to that x of symmetry. So let's do an example. I'm going to find the axis of symmetry, which is doing the opposite b over 2a, giving us the value of 1. I'm going to plug that back in to the original equation. So 2 times 1 squared minus 4 times 1 minus 1. And if you were to plug and chug that into a calculator, you would get the value of negative 3. So that's our first point. Vertex is at 1 comma negative 3. So then the next thing we're going to do, I'm going to continue on to the next slide, but it continues on your same exact example. We're going to find 2 more points. So we're going to do that by making a table of values. So by 1, we have the values of 2 and 3. You can also go the opposite direction, and you can go 0 and negative 1 if you'd like. It doesn't matter, just do 2 points to one side or the other, because then we're going to reflect it. So if I plugged in 2, I would get back negative 1. Then if I plugged in 3, I'm going to plot that point at 2 comma negative 1. And then when I plug 3 in, okay, so I'm plugging 3 in now. Again, it's 9 times 2, which is 18, minus 12 minus 1. I get 5. So that's the next point, 3 comma 5. So then after that, I'm going to reflect both of these points over. So this is over 1 this way. I'm going to draw another point to the left one. This is over 2. I'm going to go to the left 2 and then connect it. And that's your first drawing of a quadratic, which is our lovely parabola. The other thing I want to point out to you is something called the y-intercept. So with your linear equations, your y-intercept was the plus b in the y equals mx plus b. It's the constant in the back. The same thing is going to happen when we're dealing with a quadratic. So if you see where the y-axis is here, and you see where this is crossing, it's crossing at the point where x is equal to 0. So we can plug 0 in for x to find it, which is the negative 1. So what you can see here is that number matches the number right back here. So overall, what you need to remember is that the constant term is always the y-intercept. If you haven't gone back and taken notes, go ahead and do that now. I'm really looking for them for next class. All right, see you next block.